we're sort of a bit far out. I would say we're probably one of the companies with some of the more advanced techniques in terms of the way we use Bitcoin script in our application. And so just trying to get across the point of why we do it the way we do it and how that works and what that means for you as a business operator or owner who wants to build on this technology. So Bitcoin is a ledger. We all know that. Transactions come in. They're created peer-to-peer. They get submitted to the network. They're validated by nodes. But this is important. They're only validated at the end. The users actually finalize the transactions themselves peer-to-peer. They sign everything, and it's completely done by the time it hits the network. So there's nothing that a node can do to modify your transaction. They can choose to exclude it, but otherwise their job is to actually take the record of what you're doing and write it into the blockchain. And that's done within the Bitcoin protocol. It's all very, you can go and read about that all over the internet. But then in these timestamps, oh, hang on, I've got a bit of ahead of myself. It's a set of timestamps periodically found, blocks carry a reward. So in that ledger, it forms kind of a graph database. And so the edges within that database are formed in the transaction. And essentially what happens in the transaction is it points back to a previous transaction and says, I'm spending coins, a coin that was created here in this transaction, and then I'm reallocating them to a new script. And so it's that methodology of how those tokens are passed from transaction to transaction that gives the ledger its kind of utility, and that's what we primarily use when we're doing traditional kind of cash transactions, all of that sort of thing. So this is all part of the original design. This is how it works. So I've gotten ahead of myself again. I should have practiced this talk. But anyway, each coin is only spendable once. But what we have then is within that coin, so the transactions are very versatile. The protocol is very versatile. And we can put any kind of data that we like inside a transaction. And we can, in fact, put any kind of data that we like inside a spendable output inside that transaction. And it's all about how we encapsulate that data within the script that determines whether or not it's spendable. And this can be used to, you can put permanent data in there. The other thing that you can do is you can create what's called a payment channel, which is a non-final transaction. And then that transaction you can actually iterate, and you can use that as a mechanism to exchange data between parties. So I can establish a payment channel with Eli. He can send me a piece of data. I can give him a bit of money. He can give me some more data. I can give him some more money. And we're all doing that inside the piece of cash that I'm going to use to finalize the payment with him. And then at the end, once we've agreed that I've received everything I wanted and that he's received the right amount, we just close the channel, and only that last transaction goes onto the blockchain. And in that usage paradigm, we don't actually put any of the data, or very little, maybe like a hash, onto the blockchain. So, you can really use this to do anything. I think, it's not inconceivable that within, 5 to 10 years that probably most online streaming, internet services, telecommunications will operate in this way. So then we get to where the way that we are using these transactions, and this is a second layer protocol called MetaNet protocol. So it's invented by a guy named Craig, lives in London. It's second layer protocol, but it's not like the way second layers are done in the blockchain industry, where typically what you have is one blockchain who wants to do something with another blockchain, so they create a third blockchain to facilitate the transfer of stuff between those blockchains. That's not what we're talking about here. So in the MetaNet protocol, we're creating a transaction output, and then fully encapsulated within that transaction output, we're putting a packet of data that creates a second layer edge back to a different transaction that is not the one that is the parent on the public ledger. So what we're saying is we are creating like a second order graph on top of the base layer Bitcoin protocol. So what does that look like? So in a MetaNet data item, we have a pointer back to the parent. We have a signature of a public key that is in the parent, and then a new public key or set of public keys that are effectively the permissions that that new node in that database is to apply. And so if you think in the context of a business, the parent might be the board of directors, the second layer might be a department within that business, and so then within that department, we obviously put the people who operate that department as the permission layer, and we might say that 3 out of 5 of those people need to sign off on any operations that happen underneath that second order node. So what do these look like in the context of the ledger? They come in, they look like the regular transactions, but then when we distill away all of the noise, we get this kind of second layer effect where we've created a completely different database, but it's fully encapsulated within the layer 0 blockchain ledger, I guess. And so we call it like a second order datagram protocol, and you can put just about anything you like in there, and it allows you to create that second order structure without ever having to leave the network. So you do it within Bitcoin. The MetaNet protocol is completely valid within Bitcoin. It uses elliptic curve digital signatures, just like Bitcoin. It's really, it's built to embed within Bitcoin transactions. And so that means that the validation of the MetaNet nodes themselves can be pushed down onto the consensus layer of the network. And so we can actually have the nodes who process the transactions also validating that we're building our MetaNet graph correctly. So it can be used for data distribution, and there's some terrific opportunities in actually changing the way that business services operate using this technique. So there's really no restrictions on the data type or the quantity of data that you can put in. So in a transaction, you can push up to 4 gigabytes of data. Currently, I think the network rejects transactions that are bigger than like 500 megabytes, is it? I don't know. I've seen some pretty big transactions going out lately. But because it's a second order system, you have to have a second order agent that's there to be able to look at your graph and pull out the information and display that for the user. So the Bitcoin nodes aren't interpreting anything that you're doing inside your own private ledger. So this is effectively what this is about. It's using the public ledger as the base layer for you to create a private ledger on top of that. And so within that private ledger, you have complete control over who does what, where, who issues what, when, all of these kinds of things. And it's only that second order system that we're seeking to control. The first order layer, the blockchain layer, is obviously we adhere very strictly to the Bitcoin protocol. We don't want to move away from that. We don't need to change it. And so this effectively allows us to create any kind of second order system that we want. So we can put data in there. That can be weather data, that can be content, it can be social media, any kind of database. So we've got techniques for migrating legacy databases onto the blockchain. Can actually be complete web pages. So there's lots of examples out there of people who've created like a MetaNet structure, and within that structure there are pages, cascading style sheets, like everything that you need to present a cogent web interface. And what it needs then is that agent who can pull all of that out of the second layer and generate the visualization for the user. So, there we go. Application of permission. So when the root node is created, so this is the first transaction in one of these databases. Effectively, this is something that you don't need any permissions for this to happen. It's something that it's actually a two-step process. We have to create a special output that's got some script in it that does certain things. But when you create this, it's effectively you're setting the top layer permissions for your private ledger. So at the top of the private ledger, you're determining who is the entity or entities who are going to control everything that happens in the next layer down. So, and then it's for a child to be created, we have to have the first order signatures to create the second layer. But then in the second layer, we can apply a completely new set of permissions. So in this example, Gary and Cheryl can sign into existence a second layer node that Mo, Curly, and Larry all control. And so in that scenario, then Mo, Curly, and Larry can go on to create other second layer nodes that they control. And so there's unlimited scope here. There's no limits to what you can really create. And so we use this to embed kind of entire platforms. So to give you an idea, at the top level, we have like the node that represents the business. And in there, we have the directors. And then we have another node where everybody who comes and subscribes to the system, their account data is put in one part. Then when we need to issue tokens to them or whatever it is that we're doing, we do that out of another part. And so each of those different operations have different controls and different people who are responsible for them. And so this system is really great for allowing us to apply those permissions and manage them very effectively, because once we've created the second order node, we effectively don't need to stand there and watch that everybody's adhering to the rules that we've set forth, because the Bitcoin consensus layer is doing that for us. So we can sort of push that down and then let the network take care of it for us. So it's a very useful way of creating this type of structured application. So you can use this to track sort of access, activities, logging, events, all of that sort of thing. But you can use it to build very complex systems of hierarchy. So like Eli was saying, in Tuvalu and just recently in the Philippines, we're talking to some government areas over there and looking at using this to manage government services. And so effectively what we would have is at the top a node that represents the government in that region. And then if that's, say, for example, a government that has 3 branches, you'd have a separate node underneath for each of those branches. And then in the legislative node, you would have another area where they actually post the laws that they're creating, and you'd be able to see who's voted and who's agreed, who's disagreed, who said what. In judicial branch, you would have all of your court cases that are happening, and all of that would be written onto the blockchain, and anything that's public can be created in such a way that it is public and viewable, but at the same time, anything that's private can be kept private in a very robust manner. And that can be either encrypted and put on the blockchain or kept off the blockchain and just managed with like a hash and very efficient and simple. So we've heard of this talked about as the metanet will turn the internet into a side chain of Bitcoin. And I think that's actually a pretty valid way to describe it. And I see this as really a new way to actually distribute the content that we consume through the internet. And So if we think about the model that we use now, that's really client-server. So I go to Facebook, some server at Facebook. Actually, I don't use Facebook. I'm just using that as an example. But I go to Facebook. I say, I want to look at my friend's page. They go into their database. They pull my friend's page out, and they deliver it to me directly from their server to my computer. This has a lot of problems. We see man-in-the-middle attacks, security issues, DDoS attacks. We're actually hitting a lot of scale ceilings, internet infrastructure. Some of those will be resolved as we transition from IPv4 to IPv6. But you know, really, I think there are some issues we won't solve until we actually do away with this model. And part of that is the transition to IPv6. And it's important to understand Bitcoin really is built to use IPv6. And so with, where's Todd? Todd and a few other people here, we've been working with the IEEE IPv6 working group to really understand how to do that in the most effective manner and to start to create the underpinnings of this next generation internet. So in the what you might see is that I, as the service provider, would be gathering information from different people. So maybe I'm a social media service, something a little bit like Facebook. You've got an account, someone else has an account. But when I write data into my account, what's happening is that I'm actually creating my own MetaNet nodes, and I'm spending those, and I have ownership of that. And then I just tell Facebook where those are. I don't even need to tell them how to decrypt the data. I can also tell them who I share that with or want to share that with. And then when somebody comes and wants to see what I've been doing, then that's all handled in a way where, so effectively, instead of them going to Facebook and being served the data directly by Facebook, Facebook is just giving them the location of the data, potentially a key to decrypt something, and then they are using a separate provider who is just a blockchain ledger access provider to access that information. So the service provider is just telling them where it is, and then they're going to a separate third party and accessing it directly. And so in that scenario, it becomes a lot more difficult to attack that social media provider because the amount of information they're actually serving out to each person is very small. So with DDoS, you know, it's sort of very hard to overwhelm when you're only handing out little tiny amounts of data. And then so in terms of that MetaNet service provider, that would be something, you know, akin to like a self-service provider. So, you know, they would have to take down a specific provider, but they can only really knock off the people who are using that provider. So an alternative provider would index all of the same information, and I'd be able to just hop to that provider and access the same stuff. So, you know, it's a much more robust way, I think, of building an internet-style information sharing infrastructure, and it has a lot of advantages. And so for enterprise, you know, I was talking a little bit about this before. This is really about looking at how we can structure a company's records and activities on a blockchain to make them easily accessible by the public to whom they are selling their goods and services, and also really easy to manage for them as an enterprise. And so, you know, all of the permission systems that we have is, you know, very well suited to, you know, just about any kind of business or government service. We have up to 10, we can apply up to 10 separate entities in the permission system at each layer, and that's easily extensible to, you know, whatever requirements there are. But at the moment, the default we have is up to 10. Then so when they're working within this sort of framework, each level within the company is sort of semi-autonomous. Now, obviously, if you don't know the person who's running that department and you're creating it for them, you would probably add yourself as as one of the permissions at that level. And then you can always come back later and update any part of that system. And so that's one important aspect. So even at the very top level, I can take that node that doesn't have any parent, and I can spend that into a new state where it does have a parent. So if, say, I'm a government and I go, okay, this all sounds really cool, but I don't want to do it like for everything straight away, I just want to do this one little piece over here, we can go and build that one little piece and create that database on the blockchain. And then when that department goes, okay, well, now we're going to go bigger, we're going to add all of this stuff in here, we can create that new root node, and then we just spend this one into a state where it's now pointing back to the new one. And so effectively, we've now taken this component, which was created earlier, and we've just folded it into the new overall system. And similarly, we can extract things. So if we have a big system and say a company sells a division, I can just take the parent node of that division and spend it into a new state where it now points to some other company, or where it's its own thing. And so everything that's below that now becomes detached. So it's a very interesting way of managing companies and things like that. So it's a different approach, and we like it a lot. And obviously within that, you can do anything you like, read tokens and that they can be. So tokens that are issued from within the ledger don't need to be MetaNet objects. They can just be like regular tokens and transferable under normal Bitcoin rules. But the important thing is that it doesn't matter where you are within the system, you've always got a path that you can follow all the way back to the root node. And so you can independently validate that you're in the right place, you're holding the right coin, it was given to you by the right person, and they had the right permissions to issue you that coin as a legal object. So, in terms of the actual accessibility and verifiability of what you're doing, I think it fits the bill for a lot of different applications. And so these, the tools to create everything I was just showing you are now available through our DAGDA tool, so Directed Acyclic Graph Data API. It's got everything there that you need to start using this today. It's a set of API interfaces, and it gives you that sophisticated multi-signature capability that's not really available anywhere else without having to go and spend 2 years developing the code. And it does token creation, token management. And so we at Elas can help you to integrate this. We offer integration services, design services, implementation. We can create tokens with a lot of extended functionality. Really, anything that you want can be done with Bitcoin script. Like, it is a very, very flexible and useful language. It's not what a lot of other blockchains out there are rolling out in terms of smart contracts that are sort of always on and doing stuff even if people aren't using them, if you like. They're a little bit different to that. I won't go into that too much because I've only got a couple of minutes left. But I just wanted to cover a few of the different things that we've built using this framework. So one is AMLA, which we did with Eli and Bill. How are you, mate? This is a gold bullion storage system, and so within this system, we have AMLA who are at the top. They bring vaults who have Australian Financial Services licenses into the system. They're a child of that. Those vaults can then issue tokens that represent the bullion that they store within their facility, and then they can issue, they can take those tokens and send them to AMLA, who are able then to issue a cash-like currency against them. So it's really a system for creating a gold-backed currency or gold-backed tradable tokens. It all works. It's Very cool. So please ask Eli and Bill if that's interesting to you. Another one, Manufact. Ali is not here yet, but this is all about tracking luxury goods. So we're using different industrial techniques like RFID scanning and things like that to track goods through the supply chain. And so in terms of the MetaNet, it's really about having the manufacturers of the goods able to then track what's happening within each of their facilities, and even within each of their facilities at each of the producer locations, and see who's putting what into the system at what rate, and then being able to track those goods through the system, and even to the point of being able to understand at the moment when those goods are consumed. Two-way is another one where it's again a very different application. This is all about delivery of heavy materials for the construction industry. So if you show up on a building site, you need road base, you pull the app out, and you can basically, with a few touches, order 50 tons of road base. And so the way that we're using MetaNet here is that two-way is the parent. Then we have three classes of child, which is a service, someone who wants to use the service, a delivery truck driver, and someone who's selling bulk goods. And so all three of those parties work together on each job. So either the person who wants the goods create the job, someone who's got those the materials I'm looking for bids to supply it, and once I've agreed on the supply, a job is created which a truck driver can then say, yes, I'll deliver that. And so the whole job is tracked through that process, and at the end we create a single invoice in a transaction on the blockchain that everyone can see, that has all of the details and billing, and so there's just one payment for all of that whole service, which is good if you're busy on a job site. And then the last one I'll cover today is Buzzmint, which is sort of like an NFT platform, but their focus is much more on high-value brands and using the NFTs as not just some sort of thing that you buy and sell, but as a vehicle to distribute digital content, digital goods, rights to access goods and services, things like live events, digital events, digital content, digital magazines, streaming content, and doing that all by applying the ownership rights or access rights using these digital tokens. And so the MetaNet is really useful for us there because we can have Buzzmint at the top, and then they can have brands, but then those brands can even have their own sub-brands. And so some of their customers are pretty big names, and those big names have lots of little names underneath them. So we have to be able to accommodate their need to create one kind of big system with multiple sub-layers underneath. And even like it gets pretty deep, like you've got some big media company, they've got a magazine, that magazine's in 10 countries, and so it all gets quite complicated after a while. But it's just a really elegant way of being able to deploy a system like that on the blockchain and give anybody who's interacting with those, with that content, with those assets, a really simple, green tick, you're in the right place, you're holding the right thing, this is all genuine. And that's really what the MetaNet is giving us here.
Just a quick question. Essentially, your second layer agent is effectively enforcing a second layer protocol, right?
Yes.
So I just want to ask, is that like a standard across the MetaNet, or is there a separate protocol for each use case? So
the MetaNet protocol is meant to be a standard, but it's all a bit in flux at the moment. In order to do things like multi-party permissions and spendable permissions, we've actually had to extend that protocol beyond that base spec. But we are working with the company who manages it to...
But it's meant to be standard.
It's meant to be
like
a standard.
Okay.
Yeah, that's right.
And how are they incentivized?
What do you mean?
Well, they're performing a service above and beyond what the base layer is. And the base layer is incentivized through miners that have their incentives. So how does the second layer?
Well, so because I'm just using the mining service, I'm just taking a second layer and I'm just sticking it in a first layer, and so the miners just treat it like any other transaction. They don't care what it is.
So the second layer agents are actually part of the organisation.
The second layer agent is what we do. Yeah. So we have nothing to do with the mining network other than, working with them to get our stuff onto the blockchain.
Actually, I'm going to talk to you afterwards, right?
Yeah, okay.
Thank you. Miners are basically transaction processors, if that, because I know not everyone here is from the blockchain world, but if you think miners, transaction processors. Was there a question?
Yeah, over there.
Sorry.
Hi, thanks for the nice talk. So you talked about MetaNet. How is it different from the other layer 2 protocols? For example, think of say you talked about payment channel. So how is it different, or
so the payment channel in the aspect that I was talking about, I wouldn't call that layer 2. That's like a base layer function of Bitcoin SV. So you can't use payment channels on BTC. In fact, you can't do anything that I spoke about today on BTC.
Are you talking about some kind of a side chain?
No.
Then
so what I'm talking about is regular, like a valid, fully valid Bitcoin transaction, and into that transaction I'm pushing a data packet, and then inside that data packet is a little MetaNet protocol header, and then whatever I choose to put in there. And then we then create a service that knows how to interpret that packet that's inside the transaction. So we pull that out. We have our own little database that's sitting there and processing and then managing what is happening for all of the users.
Oh, so the database is somewhat different, right?
And it's whatever's needed for the application.
Yeah, and you are putting some kind of a metadata on
yes, correct.
On the blockchain?
That's right.
The Bitcoin blockchain. Okay,
Yeah.
Thank you.
Thank you. That was Dr. Sushmita Rouge from the University of New South Wales. Thank you for your question.
Thank you.
So I was a little bit late to your talk, but so what you're saying, you're using the Bitcoin network.
Bitcoin SV network, yeah.
Okay, all right. Because, but then underneath, do you create you're creating your own network? No. So you're still using based on Bitcoin?
Yeah.
Okay, using Bitcoin.
So everything is written onto the Bitcoin blockchain. There's no second layer system or anything like that. Yeah, there's our system, but it's not a blockchain or anything like that. It's purely so dependent on the business that we're supporting for that private ledger. That's a bespoke system that knows exactly how to interpret what's happening inside that private ledger. So the advantage of being able to deploy a private ledger on a public blockchain is that within your private ledger you can do whatever you like, and you don't need to be bound to any particular protocol or way of doing things. You pretty much have the freedom to do whatever you want.
I always tell people a key difference between private blockchains and public blockchains. You can delete a private blockchain, but you can never delete Bitcoin.
Correct.
Yes. Any security testing is the question.
We have done security testing on our own back-end systems, and then it's for the customers who've requested that we do security evaluation on the front end, and that's what we've done as well. Yeah.